A rectangle is inscribed in a right triangle with side lengths 8, 15, and 17. I'm going to go ahead and label what we've got here. So we've got this right triangle. We've got these side lengths. So 15 and 8, and of course the hypotenuse here, 17. One corner of the rectangle coinciding with the right angle of the triangle. We want to find the largest possible area of the rectangle. So we don't know the length and width of the rectangle, so I'm just going to call them x and y, length and width. And because that length right there is x and this full length down here is 15, that means this down here is 15 minus x. And the reason I'm looking at that is because I'm going to use similar triangles here to find a relationship between x and y. Now we're looking for the largest possible area, and area of course, the rectangle is just length times width, x times y. But of course, in order to find the largest this can be, we need it as a function of just a single variable. And so we need that relationship that exists between x and y. So considering some triangles here, I'm going to do this here. Here's a right triangle right here. And that triangle right there is similar to this larger triangle here. And so we're going to go ahead and consider those two, and we're going to set up a proportion using similar triangles in order to find that relationship between x and y. I'm going to take this length down here for the smaller triangle. We'll take 15 minus x divided by the height of that triangle, y. And that's going to equal, and then for the larger triangle, the length down here is 15, and then that height of that larger triangle is 8. So there's a relationship that exists between x and y. And so now we can solve for one of those variables. I'm going to go ahead and solve for y. We can start here by cross multiplying, and we get 15y equals 8 times 15 minus x. And then divide both sides here by 15 and get y equals 8 over 15 times 15 minus x. And since that is y, I can now take that and plug it in right here for y. So I get my area is x times 8 over 15 times 15 minus x. And we're looking for the the largest that this area could possibly be. And so we're going to go ahead and graph this in our calculator and find that maximum point. So to graph here, we have x times 8 over 15 times 15 minus x. Graph that. We're looking for the largest this can be, so we're looking for a maximum. So I'm going to go ahead and zoom out. That's not what I wanted. We're going to go ahead and zoom out until we can find that. And there's a maximum up there. So we'll go to Menu, Analyze Graph, and we're going to find that maximum. And so we're going to click to the left of that maximum and to the right of that maximum. And there is the point. Now this, of course, these two coordinates, the first coordinate is that input, that variable x, okay? And the second coordinate is what the output of the function, which is a, the area. And we're looking for that largest possible area, so that largest possible area is equal to 30.